Now today we will start transport of carbon dioxide gas. Like oxygen, similarly here also blood is the transport medium, but 20 to 25% carbon dioxide is transported by RBC, same as the oxygen. 70% carbon dioxide is transported as bicarbonate formation, and rest CO2 is transported in a dissolved state through the plasma. So similarly, like oxygen gas, blood is also the medium for the transport of carbon dioxide gas, and it is transported by three ways. Number one is 20 to 25%, which is transported by RBCs in the blood, as same as oxygen, and 7% CO2 is dissolved state through plasma. This is also as same as oxygen, but here 70% CO2 is also transported through bicarbonate complex formation, bicarbonate formation. So now we have to study it. Number one point is that similarly as oxygen, in RBC we have already know that hemoglobin pigment is present, and there we also know that hemoglobin can capable of bind with oxygen. Here hemoglobin present and it binds with the carbon dioxide, hemoglobin carbon dioxide, and a complex is formed which is known as carbaminohemoglobin. The complex is known as carbaminohemoglobin. Actually this complex is carried through the blood. Just like the oxygen, here again the formation of this complex depends on the following four factors: partial oxygen, partial pressure of oxygen, partial pressure of carbon dioxide, hydrogen concentration, and temperature. Actually temperature indirectly affects the formation of the factor. First of all, in the tissues we have already know that partial pressure of oxygen is low and partial pressure of carbon dioxide is very high. So if partial pressure of carbon dioxide high, indirectly hydrogen concentration will also be in tissue. Partial pressure of carbon dioxide is high, it means that partial pressure of oxygen is low, and if partial pressure of carbon dioxide is high, automatically hydrogen concentration is also be high. And in the previous class we have also known that in tissues temperature is also high, which facilitates dissociation of oxyhemoglobin complex. If oxyhemoglobin complex, this complex if dissociates, it means that it forms oxygen and hemoglobin. And in tissues partial pressure of carbon dioxide is high, it means there is a more availability of carbon dioxide, and we also know that hemoglobin has a probability to bind with CO2 rather than oxygen. So the four factors: number one, partial pressure of carbon dioxide is high in the tissue, partial pressure of oxygen is low. Also temperature high, which facilitates the dissociation of oxyhemoglobin complex. It means that oxygen and hemoglobin are separated, and in this way this hemoglobin binds with carbon dioxide and form carbaminohemoglobin complex. Okay, in tissues, in tissues, but in the lung surface, in alveoli, we have already known that in alveoli partial pressure of oxygen is high and partial pressure of carbon dioxide low. So if partial pressure of carbon dioxide is lower than partial pressure of oxygen, this means that the carbaminohemoglobin complex tends to dissociates, and dissociates means it forms hemoglobin and carbon dioxide. So in tissues it forms the complex is formed because all the four factors are in favor to form the complex, whereas in alveoli the factors mainly partial pressure of carbon dioxide is low and partial pressure of oxygen is high, and the complex dissociates into hemoglobin and carbon dioxide. It means that carbon dioxide binds with hemoglobin in and form the complex carbamino hemoglobin complex in tissues and carried, and in alveoli region it disassociates. So carbon dioxide is carried to the alveoli, and in alveoli it is dissociates from the complex, so carbon dioxide is delivered to the alveoli. So formation of the complex takes place in the tissue, it is carried to the alveoli, and in the alveoli the complex dissociates. It means that carbon dioxide reached there. So this is the process of transport of carbon dioxide gas through blood. But here we have written that 70% carbon dioxide is transported as bicarbonate. We have discussed about only the 20 to 25% carbon dioxide, how it is transported. Now we have to discuss about that how 70% carbon dioxide is transported. Now again in the RBC there is an enzyme present known as carbonic anhydrase. In RBC this enzyme is present. Not only in RBC, in blood plasma also minute amount of this enzyme is present. Now what is the function of this enzyme? What it facilitates? Actually it facilitates the following reaction: carbon dioxide plus hydrogen equal to H2CO3, which form HCO3 negative and hydro H positive. It form the bicarbonate, which again dissociates into HCO3 negative ion and H positive. So this is the function of carbonic anhydrase enzyme, which enzyme is present in highest amount in RBC and blood plasma. So if RBC is in RBC, if carbonic anhydrase is present, then what will happen? In blood RBC, this enzyme present, so carbon dioxide dissolves in the blood, and with water it forms the complex H2CO3, which further dissociates into H positive plus HCO3 negative. So in RBC this enzyme is present. So carbon dioxide in blood reacts with water and form H positive and HCO3. But this is in tissues. But this incident occurs in the tissues. Why? Because in tissue carbon dioxide present in higher amount. Why? Because partial pressure of CO2 is much higher. That we have already known. So in tissues, as partial pressure of carbon dioxide is very high, so in the blood it dissolves carbon in the tissues, carbon dioxide dissolves in the blood and reacts with water and forms H positive HCO3 negative. But in alveoli, PCO2 means partial pressure of carbon dioxide is low. Then again, as it is a reversible reaction, this is again converted into CO2 and H2O. So in tissue, what is formed? H positive and HCO3 negative. But in alveoli, they again converted into CO2 and H2O, because this is a reversible reaction. It means that carbon dioxide formed the bicarbonate in tissues, and then it reached to the alveoli and released the CO2. So carbon dioxide in tissues, carbon dioxide converted into bicarbonate, then this bicarbonate is carried to the alveoli region. In the alveoli region, again carbon dioxide is released out, because this is a irreversible reaction. Once you follow the reaction, in tissue carbon dioxide plus water forms the bicarbonate, this one. But in tissues, partial pressure of carbon dioxide is too low, and this again converted into carbon dioxide and water. Back reaction, because this is a reversible reaction. Okay. And we have to remember that every 100 ml of deoxygenated blood delivers 4 ml of CO2 in the alveoli. Whereas in case of oxygen, we have studied that every 100 ml of blood deliver about 5 ml of oxygen. But here it is 4 ml of CO2. So now we have understood how carbon dioxide is transported. The 20 to 25% carbon dioxide that is transported through RBC in the blood through the formation of carbaminohemoglobin complex is similar with the oxygen as formed of oxyhemoglobin. Okay, this oxyhemoglobin complex is formed in the alveoli region and dissociates into tissue, whereas this complex formed in the tissues and dissociates in the alveoli. And another one is the formation of bicarbonate. So clear, student? This is the process how oxygen and CO2 is transported through blood medium. Okay.